Hey students, welcome. Okay, so today we shall start with the matter. Okay, and this is physics class, and I'm your teacher Subhankar Roy. Okay, so we shall start with matter. So far I can remember these chapters I taught you already in class 6. So far I can remember. Okay, and this topic already you have read in class 6, class 7, and then again in class 8. Okay, so definition of matter means what is matter. First you shall tell me what is matter. You should tell me, okay, what is matter. Okay, I shall not going to tell again the definition of matter. Okay, I just tell you one thing. Everything you are watching outside the world, everything is matter. Not only that, now you are holding a pen, a copy in front of you, your phone is in your hand, a headphone is in your ear, so all these things are basically matter. Okay, so everything you are touching, you are just watching, okay, you are feeling, all these things are matters. Okay, now you may tell me, sir, you are telling something to us and we are listening. Is the sound matter? No, of course the sound is not matter. The sound is the energy. Okay, then the question is, what is non-matter? What is non-matter? You told me what is non-matter. Okay, so far I can remember you you write in your copy that human feelings are not matter. Of course human feelings are not matter, like love, hate, etc., anger, etc. are not matter, as well as vacuum is not a matter. Okay, so these things are non-matter. Okay, so what is matter, what is non-matter, what is the difference between matter and non-matter, all these things are very much common to you. Okay, these are actually easy. Okay, now element. What is an element? A element is a pure thing. Pure thing means a element cannot be divided into two or more part. Okay, by the way, this is the chapter overview. Okay, the first unit of this chapter, matter. So element means anything that can't be divided into two subpart. That is an element. Okay, if you look at the periodic table, then all there are at least 118, means 118 elements are there. Okay, so all of them are element and they cannot be divided into two parts. Means let's say a piece of iron. Okay, so if you just break the iron, you will get another two part, and that is also iron. Okay, I am talking about that. Okay, so element is something which is totally a pure thing which cannot be divided into two part. Okay, now what is atom? We know that atom is the building block of the element. Atom is the building block of the element. Okay, so how? Let's say we know there is a nucleus, and around the nucleus there are few electrons. So this is the picture of a atom. Okay, and about the atom you shall read in chemistry. Okay, so this is atom. Okay, and so far our knowledge, means up to class 8, atom cannot be divided. Okay, but in real life atom can be divided. Atom can be divided into nucleus, and the electrons and nucleus also can be divided into proton and neutron. Okay, and now proton and neutron also can be divided into quarks. Okay, we shall talk it in our classroom. Okay, because that is a out of syllabus topic. Okay, so what is molecule? Basically molecules are the building block of matter. Okay, molecules are the building block of matter, and a molecule may consist of one or more atom. Okay, so if we talk about a copper atom, then a copper atom and copper molecule are same. But if you talk about a H2O or water molecule, so water molecule have two hydrogen atom and one oxygen atom. Okay, so two hydrogen atom and one oxygen atom is just making the molecule. Okay, so these are the molecules, and all the property of molecule should be the property of the matter. Okay, have a detailed look of the book. I shall give you the scanned copy of the book. Okay, so now motion of the molecule. Now the question is, are all the molecules of a matter are just rigid? That's mean all the molecules are at a state of rest. Yes, sometimes they may be at a state of rest and sometimes they can be in the state of motion. Okay, I have just considered one example from your book, that in case of a perfume, suppose you just spraying a perfume at the corner of your classroom, and soon after that you will find that the fragrance is just spread out in the classroom. That's mean the molecule of the perfume is spreading, means it has some motion. Okay, so this is the proof that the molecule may have motion. Okay, so the molecule can go from one place to another place, of course in case of gas or in case of liquid, not in case of solid. Okay, now kinetic theory. What is kinetic theory? Basically, kinetic means something is in motion. Okay, and kinetic theory is a large part of physics. Okay, so kinetic theory of molecule means we shall assume, of course the kinetic theory is based on a few assumptions. Okay, we assume that all the molecules or the atoms, if we talk about atoms or molecules. Okay, so in case of matter we shall talk about the molecule only. So all the molecule must have some random motion. Random motion means this type of motion, random. Okay, so random motion, it should not be any there should not be any pattern. Okay, so all the molecules must have some random motion. Okay, and the velocity of the motion also should be random. Okay, and let me tell you, if you increase the temperature, the motion or the speed of the motion will increase. Why it will increase? Because we know heat, temperature. If we increase the temperature, we have to give some heat energy, and that heat energy will be absorbed by the molecules. Okay, and as the heat energy is absorbed by the molecule will increase its kinetic energy, and kinetic energy means more velocity, more speed. Okay, so that is why if you increase the temperature, the motion of the molecule or the speed of the molecule will increase automatically. Okay, is it clear? Next, when let's say let us consider this is a container. This is a container full of some molecules. Let's say few gas molecules are here, or all these are the gas molecules. Okay, and everyone is in motion, but in a random motion. But if you just give a close look to it, you will find that all the molecules are attracting each other. Means there should be a force of attraction. Okay, so this type of force of attraction is called a cohesive force, or this phenomena is known as cohesion. Okay, that's mean cohesion means, let's say this is a molecule, this is another molecule, and the attraction between them is known as cohesion. Okay, let's say there are other type of molecules also. Now the attraction between them is known as adhesion, or this force is known as adhesive force. Let's say this is a molecule, this is another molecule. Now the force of attraction between them is known as the adhesion. So this is cohesion and this is adhesion. Is it clear? And this cohesive force and adhesive force is actually known as intermolecular force. What I am saying? Intermolecular force. So basically intermolecular force means the force which act between two molecules. Okay, between two or more molecules actually, but we shall consider between two molecules. Okay, basically when we shall calculate the intermolecular force, though it is not in class 8, we actually calculate the average force. So force between the molecules is known as intermolecular force. That can be cohesive, that can be adhesive, that doesn't matter. Is it okay? And the space between two molecules, this is also random, because we know all the molecules are in motion, so the space should not be fixed, right? This is not nobody can say that the space between two molecules should be 1 centimeter. It never be. Okay, because all they are in motion. So how can I say that how can I talk about the intermolecular space? When we calculate the intermolecular space, we just calculate average space. Okay, so that is also beyond our topic in this class. Okay, whatever. So the space between two molecules is known as intermolecular space. Is it clear? So all these things are just the starting of the kinetic theory. So basically kinetic theory means all the molecules are in motion and there should be some force acting between the molecules, and of course there should be some space that is known as the intermolecular space. Okay, now I shall talk about the arrangement of molecule in solid, after that in liquid, after that in gas. Okay, so you already read in class 6 that what is the characteristics of solid. Of course solid is the state of matter. Okay, then what is the characteristic of solid? You will tell me that solid have some finite number of free space, it is rigid, it can be heaped like that. Okay, but here beyond that we shall talk about the arrangement of molecules in solid. Okay, let's say this is a piece of solid, okay, made up of iron or something else. Okay, so all these molecules, these are the molecules of ions, they are suppose arranging in that manner. Okay, so when we shall talk about solid, we must have to know that all the arrangement of molecule in a solid are fixed. That's mean all the position of the molecules in a solid is fixed. Okay, that is why solid is always rigid. Okay, that's mean the position of the molecule is fixed. Fixed with respect to another one. That is why the solid is rigid. Okay, why they are rigid? Why the position is fixed? Because their intermolecular force, is high. That's mean the intermolecular force should have a greater value. Okay, that is why all the molecules are packed together. Okay, all the molecules are at compact stage. Is it clear? So that is why all the molecules of a solid are rigid, are fixed, and that is why the solid is rigid. Okay, and as the intermolecular force is high, the intermolecular space is low. Okay, just let me give an example. Suppose this is a molecule, this is another molecule. Okay, the space between them is like this, and let's say this is a molecule, this is another molecule, and the space between them is like this. So here the intermolecular is smaller than this one. Okay, so as a result its intermolecular force is greater, and its intermolecular force is less than this one. So we can say that the intermolecular force is inversely proportional to the intermolecular space. So when the intermolecular space is increasing, the intermolecular force will decrease, and when the intermolecular space is decreasing, the intermolecular force will increase. Is it clear? So that is why the solid is like this, rigid, compact. Okay, and that is why you can heap. Okay, next, liquid. What about liquid? So we know, let's say this is a bowl and some liquid is here. Let's say some liquid is here. What type of liquid? Let's say hand sanitizer. Okay, so this is a very important liquid nowadays. Okay, so there are some molecule of those hand sanitizer and you can pour it in your hand. Okay, so how now we can easily observe that the molecules or the hand sanitizer is not rigid enough as the solid. Why? It is not rigid because its intermolecular spaces are greater than the solid. That is why the intermolecular force, that is also less than the solid. Okay, and that is why, and as the intermolecular force are less, so they can have random motion. Okay, so that is why they are not rigid enough. They can take the shape of the bin in which you are keeping it. Okay, so this is the liquid, and that is why this is why the liquid is like this. Okay, we can pour it. Okay, next, and that is why the liquid can take the shape of the container. This is the cause. Now gas. So if you talk about gas, let's say the gas is in a container. Let's say the gas is in a container, in this type of container, okay, some gas molecules are here. So in case of gas, the intermolecular distances are greatest. Okay, that's mean the gas molecules can have highest intermolecular space. Theoretically it can be up to infinity. Okay, so that is why no intermolecular force acts between them. Okay, if you consider an ideal gas and the kinetic theory, then you should know that no interaction acts between two gas molecules. Okay, so this is gas molecules, and that is why the force of interaction is lowest. Okay, and so that gas can just occupy any volume of the container. Okay, so this is gas molecules. So there may be a question, write the differences between solid, liquid and gas on the basis of kinetic model. So you have to say that. Is it okay? Next, a topic is coming, that is surface tension. So surface tension basically applicable for the liquid. Let me tell you how surface tension acts. Let's say this is a container. And some water in it, not hand sanitizer this time. Water molecules are here. Some water molecules are here. Okay, let's consider this is the water molecule. This is a water molecule. I am considering especially this molecule, and we know all the molecules, they are attracted by their neighbor ones, and that is cohesive force or the intermolecular force. So when a molecule is here and all the molecules around it are attracting it with same amount of force, then the total force or the effective force on that molecule will be 0. Okay, so the molecules, so the force on these molecules, or all the molecules inside the liquid should be 0. That's mean the total force or the effective force. Now consider the case of this type of molecules, that's mean which are on the surface. So they are basically attracted by the molecules which is just below it. That's mean the molecules which is the surface, that is attracted by the molecule which is just below it, but no one to pull him on the upper side, right? No one is pulling him from the upper side. So what is basically happening, they are getting an effective force. Okay, and that force is forming like this, and that is why this type of force, this force, that's mean the force with the nearby molecules making the surface of the liquid a little bit rigid, not like that solid. Okay, but it has some effective force. So when someone try to enter in the liquid, let's say what to say, let's say whatever, a very small thing, just try to enter the liquid, what will happen? The intermolecular force resists the liquid. The intermolecular force resists that thing to enter inside the liquid. Okay, and these things and this type of force is producing the tension, and this tension is known as the surface tension. Why this is surface tension? Because this is acting on the surface of the liquid, so that is why this is surface tension. Okay, and very often you have seen that some insects, okay, which can walk on the water surface. Okay, so how they can walk? Let's say this is the leg of an insect and it is trying to enter in the water. Okay, suppose if you want to just walk on the water, what will happen? When you are just giving your feet on the water surface, your feet will go inside the water. But in case of insects, its leg will not go in the water surface because its weight is not enough to just overcome this force. That's mean by which one molecule is attracting another one. That is why that insect can walk on the liquid. Okay, and this is the origin of the surface tension. So the definition of surface tension you will read from the book. Okay, and this is the origin of the surface tension. There may be a question, what is surface tension, what is its origin? Okay, this type of question may come in exam. So next, let's talk about the meniscus. Okay, so before starting the meniscus, just look at here. The force acting between two molecules, that is known as cohesion. And the force acting between the wall of container and the molecule, that is adhesion. Right, so two types of forces are acting here. One is the cohesion and another one is the adhesion. Okay, now let's talk about the meniscus. So what is meniscus? Suppose if you take a very narrow tube and put it in the water, I shall show you in practical session. Okay, so suppose this is a very narrow tube and you are putting it in water, you will see that the water sometimes raises up to an extent. Okay, so this is basically, and the upper surface of the liquid is look like this, sometimes like this, and instead of water, if you take mercury instead of water, the upper surface will look like this. So you will find a convex surface here and a concave surface here. Let's say this is water and this is mercury. Okay, so why this is happening? Basically, the force of adhesion. Okay, so the force of adhesion is greater here than the force of cohesion. So as force of adhesion is greater, so it is pulling the water up. Okay, and as the force of cohesion is not strong enough, so it is not going up with the water which are adjacent to the wall of the container. Okay, and here the opposite thing happens. Here the force of cohesion is greater than the force of adhesion. That's why the surface is look like this. Okay, so you just read the cause here. Okay, figure may come from here. Okay, so this is known as the meniscus and this is known as the meniscus height, or sometimes known as the capillary height, and this type of tube is known as the capillary tube. Capillary tube means a very narrow tube actually. Okay, now formation of pressure. Okay, formation of pressure, explanation from the kinetic model. So how the pressure forms? Okay, let's say this is a container full of gas molecules. Okay, can you tell me what is the unit of temperature? Of course you will tell me, sir, degree centigrade, degree Fahrenheit, but Kelvin also the unit of temperature, right? Can you tell me what is our average room temperature? It is approximately 27 degrees centigrade. Okay, we take our room temperature average as 27 degrees centigrade, and 27 degrees centigrade, that means 27 degrees centigrade, that means actually 300 Kelvin, because we know 27 plus 273, that is equal to 300 Kelvin. So the room temperature is 300 Kelvin, and the 300 Kelvin is little bit higher than the 0 Kelvin temperature. Now you may ask, sir, why you are telling this? Because when a gas is kept at 300 Kelvin, that's mean at room temperature, all the gas molecules must possess some energy. Okay, because 300 Kelvin temperature means all the molecules have some heat energy, and due to that heat energy it must have some kinetic energy, and due to that kinetic energy all the molecules of the gas are showing some random motion. Okay, and due to the random motion they are directly colliding with the wall of the container. So all the molecules are in motion, and the molecules are going and colliding with the wall of the container directly. Let's say this is the wall of the container and they are colliding with the wall of the container, and after collision they can just revert back. Okay, after collision they can just revert back, and when they are colliding with the wall of the container they are giving some force to it, right? When you are colliding with someone, of course you will give some force with that thing or that person. Okay, so similarly when the gas molecules are colliding with the wall of the container they are giving some force to it, and when you are measuring that force per unit area, then you will get the pressure. This is the definition of the pressure. Okay, we shall talk about it later. Now just try to understand the fact. So then you will get the pressure, and this is the origin of the pressure of gas. Is it clear? And we are explaining it from the kinetic model. Kinetic model means I have just told you all are in motion, so this is kinetic model. Okay, so this is why the pressure of the gas generates. Okay, now if we talk about the conduction of heat, what is conduction of heat? Okay, suppose there is a piece of iron. Okay, you are heating it from one side. Let's say you are heating it from one side, so you can feel heat from here also. Why? All these molecules, means this rod is consist of some molecules, and this is of course rigid. So when you are giving some heat energy to a molecule, what will happen? Okay, do you know what is actually the heat energy? Means when you are heating something or heating a body, you can feel the temperature. Why you can feel that temperature? What exactly happens in that liquid, in that matter? Do you know? Basically when you are heating something, so what happens? The molecule absorb that heat. Okay, the molecule absorb that heat and it increases its kinetic energy. From kinetic model, according to kinetic model, it increases kinetic energy. Kinetic energy means not always the motion, like this. Rather this can be also kinetic energy. A molecule is here and it is vibrating. This is also kinetic energy. Let's say now it is vibrating like this, and when you are hitting it, it may vibrate like this. That means the amplitude of the vibration is greater than this one. So when you are hitting a molecule, it start to vibrate, and when it start to vibrate, it collide with its nearest one, and when it is collide with the nearest one, it also start to vibrate, and when it start to vibrate, it also collide with the nearest one, it also start to vibrate. So vibration is transferring, like you are standing in a line and someone just push a boy. Okay, like this. Okay, so the vibration is just spreading. Okay, and in that way the heat energy also is spreading, and when you touch that end you can feel the heat. Okay, and this phenomenon is known as conduction. Conduction is a process of heat transfer in solid. Okay, conduction is a process of heat transfer in solid. Similarly, this convection, this is a process of heat transfer in liquid. So I am writing it. This is in solid and this is in liquid or gas. Okay, so we are talking about conduction. So conduction is a process of heat transfer in solid. Is it clear? Okay, and we can say that we are explaining it from kinetic model. Why kinetic model? Because again we have talked about the kinetic energy. Is it clear that how heat spreads through a solid? Okay, next, convection. What is convection? Convection is the same thing, the process of heat transfer, but in liquid. Let's say this is a container full of some kind of liquid, and this is kept, let's say, on a burner. This is kept on a burner. Okay, so all the molecules are here, so when you are heating, at first the molecule nearest to the burner will absorb the heat, and when it is absorbed the heat, its kinetic energy will increase, because I have just told you the kinetic absorbing the heat means increase in kinetic energy. So when its kinetic energy increase, it will start to move and it will go upside, of course upside. And when it is going upside, the lower side becoming empty, so then a molecule from the upside will come here to fill this place, and again it will become heat, and then again it will become hot, and it will also go upside. So all the molecules will come down and they will hit themselves and go upside. So in that process, the water or the liquid will start to get heat. Okay, so this process is known as convection. This is also from the kinetic theory or the kinetic model. Okay, so this is the end of the first unit. Okay,